So welcome back, Level 2 physicists, continuing on with our electrical systems and external, this time looking at electrical current. So first thing we have to do is quantify electrical charge, which we kind of did in our previous lessons. But the symbol, remember, is lowercase q, and the units are coulombs, which is a capital C. Okay, and the charge for one electron is going to be 1.6 times 10 to the negative 19 coulombs. So therefore, how many electrons are there in per coulomb? Well, if one electron is 1.6 times 10 to the negative 19, then that means that 1 coulomb will be 6.25 times 10 to the 18 electrons. Quite a number. So the next concept we have to look therefore at is current, and it's basically how fast or the rate of which the charges are moving through a wire or a conducting material. Okay, essentially the flow of electrons. And its symbol is going to be capital I, and its units are going to be amperes, which is a unit of capital A. Okay, so current is essentially Q divided by time. Okay, so the unit for charge is coulombs. The unit for current is amperes. Therefore, an amp is essentially coulombs per second, or I is equal to the charge Q divided by the time it takes in seconds. Okay, so an amp is essentially coulombs per second. So why do electrons flow instead of protons and neutrons? Well, that's because looking at atomic structure, inside the nucleus, there's a very strong nuclear force between the protons and the neutrons. It's very hard to pull protons and neutrons away. And the electrons which orbit the outside of the atom, they're just attracted to the positive nucleus by a weaker electrostatic force. So therefore, it's easier to pull those electrons off. So in terms of electron current, electrons flow in a current down a conductor. So when you apply a force, which we'll go into later, what's going to happen is those electrons are going to begin to flow down the wire. Another important thing that you have to know is the circuit symbols. So these are the circuit symbols here that you have to know. And one way you can do that is through the kung fu electricity. Okay, so if you go onto YouTube and search for kung fu circuit symbols, you will see the associated video. And then finally, current is actually kind of counterintuitive, the direction. Okay, so when you're drawing a circuit, we always show the current flowing from positive to negative. So Benjamin Franklin here thought that the charge carrier was positive, so that means that it flows from positive to negative. That's known as conventional current, and it's the current we use. We later discovered it was actually the electron, which was the charge carrier, which means that electronic current, or electron current, moves in the opposite direction, which is, of course, negative to positive. Okay, and that's known as electron flow. But in physics, at least in this external, current is moving in the direction of positive to negative rather than the other way around.